Hi everyone, welcome to our project video Heart Disease Prediction. The project contributors include Syed Bilal and myself Wasila, and I will be beginning the presentation. So around 0.6 million people die of heart disease in the US every year. That's 1 in every 4 deaths caused by heart diseases. And one of the major ways we can reduce this death rate is an early prediction of heart disease. However, it takes a lot of time to predict heart disease due to several contributory factors. That's why in this project, our goal is to apply ML approaches for classifying whether a person is suffering from heart disease or not. So this data set was collected by CDC back in 2020 as a telephone survey, and 400,000 adults participated in it. It has around 3 lakh rows and 18 columns. Here are the column descriptions of the columns in this data set. Now moving to exploratory data analysis. As you can see, this is a highly imbalanced data set with only 9% of the people having heart diseases and 90% of the people not having heart diseases. In this graph, you can see that people with heart disease are found to have a higher BMI than people with no heart diseases. Here you can see that majority of the records in our dataset have an age over 60, and as the age groups are increasing, the occurrence of skin cancer, heart disease, and kidney diseases is also increasing. In this graph, you can see that the probability of males having heart disease is way higher than females. Now let's talk about our approach with this dataset. First, we began with the pre-processing of the data. Then we created baseline models using naive Bayes and ROC curves. Since our dataset was really huge, it was taking a lot of time to perform basic models. That's why we created a sample of the dataset with only 35% of the values in the dataset. Then we also tested feature selection on gradient boosting, which didn't really work well as the data was already very clean. After conducting an exhaustive hyperparameter tuning on sample dataset, we fit the best parameters on full dataset. Then we used SMOT and undersampling techniques to deal with imbalanced data. After balancing, we found the best parameters for each model on the full dataset. Then we decided the best model and evaluation metrics. As you can see here, there are no null values in our dataset, so all we had to do was feature scaling in our pre-processing stage. From here on, Bilal will be covering models tried and evaluation metrics.
Thank you, Wasila. We chose AUC-ROC as our evaluation metric since it works best for imbalanced data, and we have a highly imbalanced data with 8.5% positive cases only. So we chose that, and now I will just show you the models we have tried. So these are the models we found out were the best. As you can see that we chose base model as mixed naive Bayes. Then we tried to improve it by trying different parameters for each type of algorithm. And we identified the best parameters. Then later on, we found out that the recall of each of the best algorithm was extremely low. So we tried to do smooth balancing and undersampling. And later on, we did both of them. And the results were spectacular as the recall increased significantly. That's what we wanted. And we tried to find out the best parameter of that. And afterwards, we also tried stacking and voting. So voting worked best after logistic regression. So we chose logistic regression as our best model. We even tried neural networks, but that did not work. So now I will just move on to the notebook which contains top 3 models. So these are our top 3 models with logistic regression as the top one with a recall of 78% and ROC of 0.841. Then the second one was voting classifier with Smooth with a recall of 66 and ROC of 0.8436. Similarly, the third one was also voting classifier with a different configuration with a similar comparable ROC and recall. So the reason why we chose the first one was that because we absolutely cannot afford false negatives at all, and we need a very good recall because if we are predicting heart disease, so false negatives would be deadlier to the patients. So we can afford a little bit of false positives, but we can never afford false negatives. So that's why we chose this. Now we deployed the entire algorithm on the entire dataset, and we trained the entire dataset and deployed it on a Streamlit web app. This is the Streamlit web app. So as you can see that this is the Streamlit web app, and these have different features that you have to answer to, and let's just predict it. So as you can see, this person does not have a heart disease with these features. So let's just increase the body mass index and also increase that the person has a serious difficulty walking, and let's see the result. So this person, it changed to this person has a heart disease. This does not mean that the person actually has a heart disease. This means that he has to get it checked. So that was it from my side. I'll just give the mic to Wasila now.
One of the major benefits of our project is an early detection of cardiac diseases, which can decrease the mortality rate and overall complications. The available instruments in the market which predict heart disease are very expensive, so our project is making it accessible to all. The hidden patterns that we found in our dataset can be used for health diagnosis by hospitals and doctors forward. The challenges we faced included negative correlation between recall and precision. The highly imbalanced data led to inaccurate predictions. Going forward, you can try SVM and an extensive research of voting and stacking algorithms to get better accuracy. Moreover, you can also try deep learning to improve the predictive power of our models. Thank you.